Hello everyone. So this is our video abstract for a recent publication in Journal of Chemical Education called Statistical Comparison Between In-Person and Online General Chemistry Exam Outcomes, a COVID-Induced Case Study. But before diving into that paper, just have to give a little bit of context into this. And so we previously published a exam analysis paper, Journal of Chem Ed 2021, 98, 1529 is the starting page, where we basically did a 3-semester analysis of exam outcomes. And so we basically used a combination of classical and modern testing theory, statistical tools to analyze tests. And so classical testing theory, the average interdependence, Cronbach alpha, discrimination index, point by serial. And then we also used Rasch analysis, where we looked at student ability, question difficulty, as well as outfit statistics. We repeated some of the exam questions. We also implemented some test design questions, and then we tracked these metrics over time. Basically, how did this improve the exam as we progressed? And so through the Rasch modeling on the first exam iteration, we could do a right plot, which is basically student ability versus question difficulty. We also got overall exam metrics plus overall question metrics. And so the first iteration of this exam, I just kind of made up the questions as I went with no particular design and strategy in mind. And we had high item dependence. We had low Cronbach alpha, the reliability index for the exam. We had many questions that were below student ability. Also, we had a huge fraction of fair or poor questions and very little very good or good questions. And so overall, fall 2017, every exam across the board was not particularly good. And so then we implemented a few design strategies. First, the guidelines for designing new questions. Again, you can check out this list or pause and read through the list. This is the papers this came from are cited in this paper, so take a look at those as well. We also use linking questions, which basically allow us to reuse questions so we can calibrate versus previous exam iterations. And so doing this strategy, you can see the metrics, some of the metric summaries here, like the Cronbach alpha, the reliability index, the percent of questions below student ability, the point by serial, and discrimination index for individual questions. You can see across the board, the good things got better and the bad things decreased. And so the test reliability dramatically increased. The fraction of good and very good questions went up. The fraction of fair and poor questions went down. And so this design strategy worked. You guys can check it out, Journal of Chem Ed. Here's the citation there. But the major conclusions, if you don't want to read through that, is we had no evidence that the linking questions were compromised. Again, we're reusing questions, but it doesn't seem like those questions were compromised, and I'll talk about that a little bit later. Nearly every metric increased with each iteration, and so it dramatically increased the first two and then it increased a little bit more the next ones. So the linker and new question design strategies were effective, but equally important is we have a baseline of performance that we can compare against future courses, which turned out in spring of 2020, that turned out to be a very important thing because that's when COVID hit. And so we were all met with this transition from in-person to online classes. Nobody expected it. And so what ended up happening is I ended up teaching this general chemistry exam, general chemistry 2 class again in the fall of 2020. And so at that point, we were entirely online. And so with the online transition, we had online lectures, which you can see. Again, Ken's talking head in the corner. We're doing Zoom lectures entirely. But it also transitioned us to online testing. And in our case, that meant giving exams on Canvas rather than in person. And there's a lot of concern with this, right, in terms of like how will students perform, what's the impact on cheating and things like that. And so ultimately we had a baseline from our previous study, and we got to perform an experiment saying what happens when we move the tests online. And so we decided our testing strategy was going to be students take the exam on Canvas. They can take it anywhere. They don't have to be, a specific place to take it. They can take it from home. They have an equation sheet and calculator just like previous exams. But one of the big things we chose to do is no proctoring on this exam. I know there's a lot of contentions about, using honor locks and things like that, but if you look at literature, there's mixed feelings about whether those online proctoring softwares actually help or hinder cheating and things like that. And so we decided to do the experiment. We did no proctoring. And so ultimately our goal was to compare the in-person and online exam outcomes. And so one of the ways we did that, as I mentioned earlier, was with the use of linking questions. So basically taking some high quality questions from a previous exam, transplanting them on a new exam exactly the same, and this allows us to do something called equating. And so here's just an example from the, you can see Practitioner's Introduction to Equating by the CCSSO. And basically you can have two independent exams, but as long as a few of those items are the same, you can effectively use those as a calibration curve. And so you can see here items A, B, and C being reused on this other exam, A, B, and C. And so as long as the difficulty distribution is similar among these two implementations, those questions, you can effectively use those as a calibration point. And you can basically say, okay, the difficulty of A, B, and C should be the same, and so we can calibrate the other questions versus it. And so that's what the equating procedure effectively is. And so in this case, you can tell that this exam is a more difficult exam than this one. And so it allows you to basically put all exams on the same difficulty scale. Not only that, but it also lets you, through the right plot in the equating, that you can equate student abilities on the same scale. And so a really powerful tool if you implement these linking questions. And so we did that comparing fall of 20 versus the previous 3 semesters. And you basically get an equating plot that looks something like this, where the x-axis is previous performance, and then the y-axis is essentially performance on the new exam. And so you can see across exam 1, 2, and 3 in the final exam, basically you have a really good equating fit. And so this diagonal line here, that's what it would look like if it's perfect equating. It's basically a slope of 1, and you can see that there's a nice distribution about this. There's no strong outliers either direction. Likewise, you can see the student ability graph, where we basically take that right plot and turn it 90 degrees, and we get a graph that looks something like this. And so we can compare student ability as relative to the corrected difficulty comparison between the exams. And you can see there's no dramatic difference for the fall of 2020 versus the previous exams. And so again, major conclusions: there's no outliers in the equating procedure. We had similar ability distributions across all the exam. And overall, we just saw no evidence for a profound increase in cheating. Again, if there was cheating, essentially this line would start to slope towards 0, and then we might see a huge bump in student ability because of the cheating and performance. But we just didn't see that phenomenon. So it led us to believe that we could give online tests even without proctoring, and we could still accurately assess our student, at least as accurately as we had done in person. And so that became really useful because in basically after fall of 2020, starting in spring of 2021, we started to transition back to in-person classes, at least especially in Florida, where COVID apparently ended about that time. And so we continued our experiment, but instead of, we went back to our in-person lectures that we had before fall of 20, but we kept online testing. And online testing was really useful in terms of, it's easier to do the statistical analysis. It's better for students because they don't have to spend time getting ready and driving in, especially for an 8 a.m. class. And so we decided to see what happens when we do online classes. And so now we can compare across all the semesters, right? We have 6 semesters worth of data, three semesters in person, 1 semester entirely online, and then 2 semesters in-person lecture and then online testing. And so we have the, overall exam metrics, at least comparing across exam 1. We also have the per question metrics here. And so you can take a look at those, but summarizing those graphically, you can see the Cronbach alpha over time, as well as the discrimination index and point biserial for each individual question. The take-home messages, basically you can see what we saw earlier is that, as our design strategy got better, we can see a dramatic increase in the reliability of our exam. But you can see across the subsequent 3 semesters, it varies up and down, but there's really no dramatic increase or decrease. I mean, maybe a little bit of a drop in fall of 20, but you see similar variations in fall of 22. There's just not a huge dramatic change. Similarly with very good and good questions, they largely plateaued after the first 3 semesters, and the fraction of fair and poor questions remained relatively constant, but much lower than the good and very good. And so basically the take-home conclusion we had from this is there's no obvious difference in performance, whether it's the quality of the questions or the quality of the exam. It seems like overall, regardless of the delivery mechanism, they were very similar. And so looking at our equating plots as well, we wanted to see, is there any indication of cheating? And as far as we can tell, there's not. There's no outliers here where you would expect if a question was compromised, like every student had access to a given previous exam and these equating questions were there, you'd expect outlier data points that were up here, or something goes wrong and data points are down here. But we don't see that. We see a fairly even distribution about this ideal equating line. So everything's within, 0.5 log it of that line. The other thing we see is that the slope is pretty close to 1 across the board. And so if there was rampant cheating in the class, we'd effectively see all these data points start to converge on a slope of 0. Basically, if there's cheating and people have access to these questions, the difficulty distribution should effectively narrow. And so all the questions, rather than be spread out in difficulty, they should be essentially aligned. And so the byproduct of that would be you'd effectively get a slope of 0 or approaching 0. And so you can see here that the online classes actually had a slope closer to 1 than, say, the in-person, that were more approaching 0 than the online. And so, again, a couple conclusions of this is there's no obvious increase in the prevalence of cheating in the online proctored exams. We don't see outlier questions. We also don't see a general change in the exam difficulty based on this equating plot. And so either the students don't have access or they do have access, and it doesn't really change the outcomes of this exam, at least based on the statistics we're looking at. And so again, it's a surprise for us, but some precedent in the literature. And so the other thing we can do is we can look at student ability over the various different semesters. And again, if there's a profound prevalence of cheating, you'd expect the ability of the online students to be much higher than the in-person students. And that's just not what we saw. And so here you can see across exam 1, 2, 3, and the final, the various different semesters, it's all over the place. And so it's kind of hard to look at and analyze in this form. And so what we did is we used Cohen's d. This is basically you take the mean and divide it by the pooled standard deviation, which is this equation here, and it basically gives you not just the direction of change but the magnitude of change. And so anything highlighted in orange or blue are statistically notable changes. But as you can see, ignoring fall of 17, which is a terrible exam, you can see basically across the board we have decreases, increases, increases, decreases, increases. Basically the take home here is that if we were going to expect some kind of cheating or some kind of failure of the exam to assess the students accurately, we'd expect an across-the-board drop or increase for the online exam versus in-person, and we just don't see that. Sometimes it goes up, sometimes it goes down. One thing to note is as we progress, the magnitude of the variability actually decreases because the accuracy of our assessment is increasing, and so that was really exciting to see. But again, overall, there's just no indication that there's a dramatic difference between the online and in-person exams. And so, yeah, this is the summary. Major conclusions we saw, across the first 3 semesters as we implemented this design strategy, the reliability went up, the fraction of good and very good questions dramatically increased, but then it largely plateaued regardless of median. And so whether it was in person, in spring of 19 and fall of 19, or it was online or combination of online test and in-person lecture, it largely plateaued. And we saw no evidence of compromised questions. And so the question quality and the question difficulty remained relatively constant, as demonstrated by the equating procedure as well as the just performance metrics on the questions. And so again, there's no evidence of increased cheating. There's also no evidence that student abilities suffer dramatically on online versus in-person exams. And so again, a shock across the board, but this is kind of a non-study in the sense that's saying it didn't matter whether we were in person and online. And then again, something important to iterate about that is it was an unproctored exam, and still there was no evidence for increased prevalence of cheating. And so a surprise across the board. But if you want to see more details, there's the reference Journal of Chem Ed, or you can look in the comments for this video. You can get a link directly to this study. So we'll close with some acknowledgments. My collaborator on this is Benjamin Sorensen, who is a statistician / data scientist who helps me out with the data processing and also equating and things like that. But also to the teaching assistants from fall of 17 to fall of 2022. They help me write the exams and double check the question quality and things like that. And so I really, really appreciate their help. And with that, normally I'd ask for questions. You guys can email me if you have any, or check us out on Twitter and Instagram if you like pretty photos. We'll tweet out this video as well. But with that, thank you for listening, and keep your eyes out for future test analysis studies from our group.